I'm going to go through what we would have done in class. So we had talked about circular functions, and we're still using a unit circle, but for the moment we're just going to be focusing on the relationship between the angle and just the y value, right, just the sign. So if I was going to fill in this chart, when theta is 0, the y value is 0. When theta is pi over 2, the y value is 1. When theta is pi, the y value is back to 0. 3 pi over 2, the y value is -1, and 2 pi, it's back to 0. Negative pi over 2, it's -1, 0, positive 1. So if we look at these numbers, we start off at 0, 0. At pi over 2, we're up at 1, then down at 0, then at -1, then 0. At negative pi over 2, we're at -1, 0, 1. So you can see this wavy nature, this periodic nature. So this is our sine curve. And one thing that we can notice is that this has rotational symmetry. If I was going to rotate this 180 degrees, I'd get the same looking graph. So this tells me that sine of theta is an odd function. And we had already been saying that, right? We had said that the sine of negative theta is the same thing as the negative sine of theta on the unit circle. We're going to do the same thing for question number 2, except we're looking at the x values. We're looking at the cosine. So when x is 0, when theta, is 0, our x value is going to be 1. When theta is pi over 2, our x value is 0. When theta is 180 degrees, or pi, our x value is -1, and then 0 again, and then 1. And the same thing is true if we go in this direction. When theta is negative pi over 2, our x value is 0. Then -1, then 0, and up. So here's the graph of our x value. Here's the graph of cosine of theta. And what you can see is that this is perfectly symmetric over the y-axis. So cosine of theta sure looks like an even function. It's symmetric over the y-axis. And we, in fact, had said that. Really, the definition of even is that the cosine of negative theta is the same as the cosine of theta, which was clear on the unit circle. Okay, so let's do a few transformations. So if I want to find cosine of negative theta, well, this is just going to be a reflection over the y-axis, over the y-axis. So when I reflect it over the y-axis, well, because this is even, it's going to look exactly the same, right? And it's the same because cosine is even, right? So this is the same graph, which is quite different than if I put a negative out in the front. This is then a reflection just over the x-axis, right? So instead of starting up at 1, this is going to be down at -1, right? So this is just going to flip the entire graph that we had. And it's important that you get these points in. Okay, so this is negative cosine of theta. And it doesn't really show anything, right? There's nothing that I recognize from that. Sine of negative theta, well, just as before, this is going to be a reflection over the y-axis. You remember reflections from Algebra 2. Sine of negative theta. I'm going to take my sine graph. Let's just remember what that looked like. Sine graph looks like this. And I'm just going to reflect it over the y-axis. So this point, which had been at 1, is going to be at -1. Is at pi over 2, 1 is going to be at negative pi over 2, 1. And everything's going to sort of follow. Okay, so here I am, reflecting sine over the x-axis. So, and it's not the same, right? So this is sine of negative theta is not the same as sine of theta. And here, again, we're just reviewing. This is a reflection over the x-axis. So instead of going up, I'm going to go down. Reflection, I'm taking my sine graph and just reflecting it over the x-axis. But what I do notice is that these two graphs are identical. So what I notice is that when I take the negative sine of theta, that is exactly the same graph as the sine of negative theta. Again, not a surprise, because sine of theta is odd. Now, this is going to be a translation. So when I add pi, I'm going to take the graph of sine of negative theta, which is this one, and I'm going to shift pi units to the left. So I'm going to take this graph and I'm going to shift it pi units to the left. So this point over here at 0, 0, I'm going to shift to negative pi 0. So let's see, I'm going to rip this up. So this point is going to go to negative pi 0. This point, pi over 2, negative 1, I'm going to shift right over here. This point is going to be shifted to the origin. This point is going to be shifted over here. This point is going to be shifted over here. This point is going to be shifted over there. Let's see, this point is going to be shifted over there. This point at negative pi over 2 to negative 3 pi over 2. Okay, so here we go. Okay, so again, this is sine of negative theta plus pi, which is interesting. The sine of pi minus theta, I'm going to write it that way, is the same as the sine of pi, and that's something that, in fact, we have been saying all along. Well, let's look at this.